Hello, and welcome to the third week of Skill Sprints, focusing on modernizing your VCL applications with RAD Studio XE7. My name is Brian Alexakis, and I am a Product Marketing Manager here at Embarcadero Technologies. This week we will take a look at how to leverage the new Parallel Programming Library. This skill sprint will provide an overview of how RAD Studio XE7 streamlines the integration process of leveraging multiple core systems with the parallel programming library. In today's modern computing world, multi-core CPUs are not just found within desktop systems, but are on smartphones and smart devices. The new parallel programming library exponentially increases performance of multi-threaded VCL applications to take advantage of multi-core CPUs. Here is the weekly lineup for this ongoing Skill Sprint series, which continues through the end of the year. Last week, we covered how to more deeply integrate with modern Windows OS features using taskbar buttons, jump lists, and gesture input. Next week, we will take a look at new language and RTL features. To view the full schedule online, please visit embarcadero.com/landing-pages/skill-sprints. Each skill sprint during this season has a complimentary blog post on community.embarcadero.com. Here you will find all links displayed, source code for the demos, and online replays hosted on YouTube. You can also find all of the skill sprints from Embarcadero on our YouTube channel. You will find not only the skill sprints from this series, modernizing VCL applications, but from past skill sprint videos as well. As always, I will display all links featured in today's skill sprint at the end of the presentation. So why care about modernizing VCL applications? Well, Microsoft is no longer supporting Windows XP, and Windows 7 currently holds the lion's share of installations. Windows 8 installs are on the rise, and Windows 10 is right around the corner. The Microsoft user interface has changed a lot over time. Windows 7 has evolved from Windows XP. Windows 8 and Windows 10 present even greater changes. Microsoft has taken the Windows UI/UX paradigm in a new direction to account for the modern computing experience, including things like larger displays and touch interfaces. New styles, which Microsoft refers to as modern UI, were established to accommodate these new features. And if your application is still tuned to the Windows XP paradigm, then it's going to feel dated when running on modern Windows, as users expect apps to have these new features. With RAD Studio XE7, bringing your app to the current and future version of Windows is in general a smooth migration process. A complete recode is not going to be necessary, and the experience of our customers doing this migration has been reported as smooth. This creates a very cost-effective way to bring your VCL applications to the modern age so that it can take advantage of all of these features. The Parallel Programming Library was introduced for Delphi XE7, C++ Builder XE7, and RAD Studio XE7, and it is compatible with VCL applications. The Parallel Programming Library is available for use with both Object Pascal and C++. The system threading is a new library focusing on three main areas: parallel for loop, tasks, and futures. Currently, there are some limitations with futures in that it is only supported within Object Pascal. System threading allows you to easily add parallel programming to your applications to take advantage of multi-core and multi-processing technologies. This also includes smart devices, and mobile devices, which today frequently have 2 or more cores. The big advantage here is performance gains due to the ability to spread your application logic across multiple threads within the operating system it is running on to the multiple cores it knows about. Using the parallel programming library means you don't have to implement threading at a low level, and in turn will save you a lot of development time. The implementation is compatible across all platforms. Same library, same interface, whether you are programming against Win32, Win64, Mac OS X, Mac iOS, or Android. Before we dive into some demos, I'd like to take a moment and touch on some aspects of the implementation of the parallel programming library. The operating system knows how to schedule for the different cores that it finds. The parallel programming library uses threading that is aware of what's going on within the CPU and does a lot of self-tuning for you. You can create your own thread pools if you choose to, and that thread pool can also self-tune itself based on what's happening within the CPU. You can pass them as parameters and change what's going on for the benefit of your algorithm. We aren't going to go deep into the underpinnings of the parallel programming library architecture during this skill sprint, but Alan Bayer has a great Code Rage video in which he goes into the details about the implementation of the parallel programming library at a hardware operating system level. I will be linking to this video at the end of this week's skill sprint. The for loop has an iterator that allows you to do the processing inside of the for loop, especially handling the index that you're processing through in the for loop. There's a break parameter to break you out of a given iteration within the for loop, and you can have more control of the for loop to see where you are in the iteration of the for loop. The TTask class allows you to start one or more tasks and wait for completion of one or all of these tasks. Features are still being worked on for C++, as I mentioned earlier, but they are ready for use within Object Pascal. This demo will demonstrate a task in action. This will be C++, and I will follow up with an Object Pascal version. When this button is pressed, a task will get fired off and will just generate a random number and update the label. This scroll bar at the top will bounce back from the left and to the right to demonstrate that the task will not lock the UI. Let's just jump into the code here really quick. If I look at the event handler for this button, first thing that happens is the caption gets updated to a couple of dashes, and then the TTask run is called, and we create an object here out of the TCPP task, passing in the L value and label. The L value is just an integer defined within the top level class here, and the scroll bar direction is used to animate the scroll bar direction is used to animate the scroll bar on the form designer. So when the task run is invoked here, this TCPP class here will get called, and the invoke function is right here. It's extending the TCPP interface to object, and when this does run, it will sleep for 3 seconds. The random number gets generated, and this kind of simulates some kind of a background task of some kind. And then after that's done, the tthread synchronized is called, and a new TCP sync object is created, and this class here basically it extends the TCPP interface to object, and it in turn is invoked once the synchronization occurs, and the caption just gets updated. In order to use the threading classes, we are including the system.threading.hpp here at the top. Okay, it's pretty straightforward. Let's go ahead and see what happens when this gets run. Oh, and one more thing, here's the timer update. It basically looks for the two edges, whether it's 0 or 100, and just changes directions and animates. So let's go ahead and run this. Okay, and I will click the button, and the thread is running, and 3 seconds later the number is generated. And as you can see, the UI is not locked, it continues to run, and I can move the window about and continue to use the application while that thread is running. Here we have the Object Pascal implementation of the same demo. The setup is the same components. Let's go ahead and jump into the event handler for the button click. First of all, the system.threading is included here, and it is basically the same logic, although the big difference here is that TTaskRun is using a lambda function and is defined in line right here. So again, here it sleeps for 3 seconds, generates the random number, and we actually have yet another lambda here for the synchronization event that updates the caption to the string. The timer event is down here, is the same, and so let's go ahead and give this a run. And as you can see, when the thread is run, that the UI does not get locked. This next demo we're going to take a look at will analyze how a for loop can be parallelized within C++. The objective is to show the number of prime numbers that are contained within a given range of numbers and to see how long it takes to calculate. We have two buttons on the form designer and a memo. The first button is a traditional for loop, and the second button will activate a parallelized for loop. If we examine the code for the traditional for loop, we can see that we are going to look at a range of numbers over 50,000. TOT will keep track of the number of primes found. Here we are starting a stopwatch to keep track of how long it takes for this process to complete. And then we enter a traditional for loop over a range from 1 to max, and each value is tested whether or not that is a prime number or not. This is just a helper function written up here that just tests whether that passed in number is prime. And for each prime number found, TOT is incremented. After the loop is completed, the stopwatch is stopped, and the results are outputted to the memo in terms of how many milliseconds it took and the amount of prime numbers discovered. The parallel button, contrastly, does the same thing, but instead of using a for loop, it uses the tParallel for and passes in the range and this myIterator event value. That is a function that we've written here, and it also uses the isPrime helper function, and we use the tinterlocked increment to increment the TOT value by 1 within the context of the parallelized for loop. Once that for loop is completed, we stop the stopwatch and we output the results. Let's see this in action. If I click on the for loop, you can see that it took 374 milliseconds and found 5,134 primes within the values of 1 to 50,000. And if I do the parallelized version of that same for loop, you can see that it is quite an improvement of over 3 times quicker. And this really does represent the kind of benefit that you can expect to find when you properly parallelize your application logic. Let's take a look at that same VCL application, but implemented within Object Pascal. We have two buttons on the form and a memo, just as before. The first button is linked to a traditional for loop, and the second button is linked to a parallelized for loop. If we look at the code, we can begin by examining the isPrime helper function, which basically does the same thing as the C++ equivalent, testing whether the passed-in value is a prime number or not. We're going to loop over 100,000 values as opposed to 50, so we can see the increase in performance. It will be even more dramatic for this simple demonstration. The for loop event handler is defined here for the plain old for loop. And here it is here. Similarly, it is keeping track of time with ticks, and once it calculates the number of prime numbers and the duration that it took, it just outputs to the memo line. The parallelized version of the same for loop is defined here, and it's in line, defined in place, with it as a anonymous function within the for loop method call here. And it also uses the interlocked increment to increase the number of primes found, again with respect to the parallelized for loop. After it finishes, it calculates the amount of time that it took and outputs it to that memo. So let's go ahead and run this. If we do the plain old loop, we can see that it took 1,279 milliseconds and found 9,593 prime numbers. The parallelized version only took 421 milliseconds and found the same amount of prime numbers. That's quite the increase in speed. I would like to bring to your attention a few offers that we have going on at Embarcadero right now. The first of which is a book by Nick Hodges regarding coding in Delphi. It's completely free for download until November 21st when you activate your RAD Studio XE7 trial. We also have a free Rapid SQL XE6 bonus pack, which is also available until November 21st. If you'd like to get some more detail on any of these offers, please visit embarcadero.com/radoffer. If you have missed a skill sprint from the first 2 weeks, they are now available online as a replay. You can find more information, including links to YouTube replays and source code, on my community blog at embt.co/blog-com-brian. If you want to check out all the skill sprints Embarcadero has produced, you can visit the YouTube channel at embt.co/vcl-skill-sprint-YouTube. There are some great videos covering the parallel programming library in detail from CodeRage 9. They are now all available online on our YouTube channel. The first one that I would recommend checking out is Bruno Babbitt's excellent Consuming Object Pascal code from C++. It covers C++ 11 lambdas as well as Object Pascal anonymous methods. And in particular here, lambdas are very handy to simplify the use of the new parallel programming library, as we briefly touched on today. To get a deeper understanding of the implementation of the parallel programming library, you can consume either the Object Pascal or the CPP flavor, and I link that here on the screen. Lastly, I'm linking against Stephen Ball's technical blog covering the topic of the parallel programming library. He goes into detail using futures as well as thread pool. Thank you for joining me this week. Next week we're going to be covering new language and RTL features, and I will now turn it over to Q&A. I'm joined here today with David I, and we already have a couple of questions.
Hi, Brian. Hi, everyone.
Hello, David. Good morning. Oh, okay. So, first question is, does this mean that VCL is now thread safe? And David I'll let you go ahead and respond to that one.
No, the VCL is still not thread safe. You still, as you saw in Brian's code, you still have to do synchronize and in your code if you want to do an update of, for example, a UI element. So that's still the case with the VCL and with FireMonkey as well.
Thanks, David. Next question here is, does the parallelized for loop automatically dispatch the iterator events to all available cores?
And the answer is yes. The library starts threads, and the operating system does the work of assigning threads to cores. So that's done under the covers. There's no special code you have to write to control how many cores are used. That's really up to the operating system. You can create your own thread pools. Otherwise, you'll have the standard thread pool. So take a look at the library and Alan Bauer's session, as well as Danny Wind and my sessions from Code Rage, where we talk about what happens under the covers of the operating system. But yes, it will. I think Serena did an example on her blog earlier, maybe a month ago or so. She had 8 cores running on her Macintosh all at the same time.
Okay, our question is, can you control the number of threads or cores to use?
And for the first part on threads, yes, you can create a custom thread pool. There's an optional parameter for the parallel library calls. The best way is to put down a parallel for or a parallel task, and then use parameter insight for the parameters you pass, and you'll see several overloaded parameters, including a thread pool. So if you want to control the number of threads, you can do that yourself. Otherwise, the library self-tunes. It does it on its own. If you're running on Windows, there's Windows API calls if you want to special case your code for doing something or restricting what's going on. But otherwise, the parallel library self-tunes based on the operating system that it's interacting with.
Thank you. Okay, our next question is, can you use the parallel for with a data set, and how does it allow each thread to be on a different I'm sorry. Let's see. I'm having trouble reading that one. How does it allow each thread to be on a different recording the data set? I don't know, David, maybe you can.
Oh, I see. There's some missing spaces, it looks like.
Yeah.
You can do parallel with data sets or arrays or any other operations you want. He says he wants to have separate threads for working with different records in a data set. So you can do that. You would just either create a task or maybe do a parallel for loop where you're iterating from 0 to the number of records in a data set minus 1. It's definitely possible to do just about anything that you want with any type. If multiple threads are going to work on the entire data set, then again, synchronization, protecting who's using what is part of what's going on. You saw that in Brian's example with a simple integer example where he needed to make sure that no other task or part of the loop was updating that integer variable for the total number of prime numbers, for example. But yeah, you can use parallel with anything, including long-running SQL calls, operations, and so on. Take a look at my session in Danny Wind, WIND session on for examples of again how we did use the parallel library.
Great. Our next question is, can we use the TList on the parallel loop?
Again, as I said, you can use just about any type or any storage or any structure that you want. So you could have a list of whatever and pass different elements of a list to different tasks, or have them work on it, or in a parallel for loop, do a for loop through the items in a list. And again, it will pass those parallel for operations off to different threads and to different cores that might be available on your system. So You can go down the list of any object you want to list, pun intended, and you can use it with parallel. And again, though, if different tasks or different threads are going to want to work on the same items in a list or the same storage in a memory structure, like a data set, then you have to make sure that you control which thread has access to those things. But otherwise, you can do it with any object. And again, I want to mention, as long as you know in your code, for example, on a TList or a data set, that each of a parallel for or a task are only going to be accessing one item at a time, you don't need to do any protection. That's you and your code. Just do a parallel for loop, and each for loop item goes through a different element of a list or a different record of a data set, and everything will be fine. You won't have to worry about keeping track or protecting items. It's only in the case, as always, where multiple tasks or multiple loop elements might want to access the same or update the same item, whatever that might be. And it looks like Spiros was saying, using the tthread object, the tthread object still exists, the thread unit. You can still use tthread like you have always. The parallel library is built on top of the lower level threading object, which then does the interfacing to the different operating systems, whether it's Windows, OS X, iOS, or Android. So you could do the same things you want with threads. It just makes it simpler now in Object Pascal and C++ to use the parallel for, to use the task, to use the future. So use the new parallel library. It works in a similar way under the covers. It's still the operating system and the processors themselves. So Spiros, again, you can continue to use tthread object or use the parallel library.
Thanks, David. We have another question here regarding the t-task threads and the ability to list them and to arbitrarily kill them at any time.
There are several different ways of doing things. You can start a task, you can stop a task or cancel a task, you can check the status of each task, you can wait for any task to complete or wait for all tasks to complete. So take a look at the t-task example and that we did in the recent code rage, and you'll see those options. The other way is to have exe7 and create a t-task and say t-task dot run or and see what the options are. Use an iTask, which is the interface to a task, and put the dot or the colon and see what your options are, and you'll see all of those kinds of operations listed. Create a task, start a task, cancel a task, get the task status, wait for any task to complete, wait for all tasks to complete.
Okay, looks like we have another question here about having distinct variables within threads.
Can you have distinct variables in each thread? If you have anonymous methods inside of a task or a loop as part of your operations, or each can have a local variable. If you decide to, for example, is prime that was called from each item of a loop can have its own local storage. I think it ran through a for loop, so you can have local variables just as you would always have local variables. And then I think not total number of primes, but I think Danny Wind and Bruno had examples where they were adding up or the random numbers that were coming in to get a total value. It might have been Bruno Bebe's example, and the source code is available. Look at my blog post about Bruno's session, and I give you a link to the zip file. It was a C++ one, but the code's pretty straightforward. So you can do all of those operations, have a global variable that you would then update in each for loop item or task item, and Then, if you're accessing the global variable, as each loop or task would be updating that, you'll have to protect that global storage while you're doing the update. But as you saw in the example, that's a simple call. So, yes, you can, Keith. And I guess Jan, or Jan, sorry if I did it wrong, is the PPL feature unique, or does it also exist in Visual Studio? Well, you have to look at Microsoft. The PPL is very similar in architecture to the .NET Parallel extensions, which may be available to MS Visual Studio. I did a matrix manipulation, a matrix, matrix multiplication example a little while back, and all I did was take a Visual Studio C# example and convert it to Object Pascal and C++. So it's very similar. Very similar to Apple has a multi-core parallel library. Intel has threaded building blocks. There's a lot of different systems out there. They're all very similar in the way they work, and ultimately underneath it's being handled by the operating system interfaces to the hardware. So, threading is in everybody's world, and having these libraries which sit on top of the threading in the operating system are coming out because of the advent of multi-cores, both on desktop computers and mobile computers. So it's a good thing, and it works with your VCL apps and with your with FireMonkey apps. And Peter's saying he likes it very much. It's very cool. Thanks for that. Let's see. Ross is saying if I have a lot of objects and I need to find the one that's using the parallel speed up, need to sync, or well, if you're trying to figure out where things are spending time, you can use the stopwatch object. We use that, for example, to do the timing calculations for the parallel prime number. For prime numbers. So there's the TStopwatch is a class that gives you very precise timing. So if you want to figure out where your which of your parallel operations are taking the most time.
Regarding a T-thread in the code, will there be a change in the results with the new library?
Nothing if you're using T-threads. The parallel programming library is built on top of T-threads, so it uses the same underlying operating system interfaces. You can keep using T-threads in your applications, but if you want a parallel for loop, if you want to be able to run tests or use a future in Pascal and eventually in C++, then you can add those and use them in addition to any T-thread based applications you're already building.
Is there a way to show the specific cores that are being used in a given time?
On each platform, for example, on Windows, you can look at the task manager and see the cores. On the Macintosh, you can see the cores in About Your Macintosh and look at the CPU performance, and you can see the cores. Serena did a blog post and I think a skill sprint, or it may have been part of the XZ7 launch video replay webinar where she showed 8 cores running on her Macintosh. On the devices, I'm not sure, but if you're asking in your own program to show the cores you're using, there may be, and there probably is, a Windows API to get into the task manager and see what cores, but there you'd have to do your own programming. Otherwise, just bring up the task manager.
Well, I think that's about it for today. I appreciate you guys joining me, and I look forward to seeing you next week. Have a great day.
Yeah, thanks, everyone. Take care.